Welcome to the Women in Industry podcast. My name is Kirsty Davies-Chinnock, and today I'm joined by Zena Carden, who is the Technical Director of Trent Refractories. You may remember we spoke to Katie Moss from Trent Refractories a few weeks ago, and Trent Refractories are a customer-focused, UK-based manufacturer and supplier of bespoke refractory products and solutions, supplying the UK and global markets, and services at the heart of everything they do. So welcome, Zena. How are you?
I'm good, thank you. How are you?
I'm not too bad. You said just before I hit record that 10 minutes ago you were climbing on top of an oven.
That's correct, yes. That's the joys of my day today so far. 10 past 10.
um, Katie covered what refractories do, but perhaps you could put it into layman terms for me, and remind the listeners what it is that Trent Refractories actually do.
Yeah. Well, in terms of refractories, then, it's not an item that most people know about. Certainly when I joined the industry, I had no idea what refractories were either. But really, they touch every part of our lives. So everything that needs any kind of high temperature processing, then they'll need some form of refractories to line and protect the surrounding steelwork. So here at Trent Refractories, we manufacture monolithic materials, which we can either supply direct as monolithics, which is essentially just like a civil concrete that you can go and buy at your local DIY store, or we can actually then mix that and then cast that here to form precast shapes. And we can do that in a range of sizes, ranging from just 1 kilogram up to 10 tons of material. And these go into a range of different industries and applications. So the most obvious is steel and iron making, but things like cement, aluminium, all the iron foundries, plastics, hydrocarbon processing, incineration, they all need some form of refractories in terms of those applications. So it really does touch every element of our everyday lives.
And you said when you first started that you had no idea about refractories either. And when I was talking to Katie, it's so obvious when you think about it that if you're going to melt metal or concrete or iron steel at really high temperatures, you need to make sure that what you're melting it in doesn't melt itself.
Yes.
So it's really obvious when you think about it, but of course most people don't think about these things. So when you started, why did you start in refractories? Did you sort of join by accident or?
Yeah, pretty much. It was pretty much an accidental start in life. So when I left sort of school and did my A levels, I very started on a part-time job, and very nearly went into sort of retail. So I sort of got a Saturday job, started off there and sort of progressed through there, and they were putting me through sort of managerial training. And I was applying for different jobs because I wanted a vocation rather than just a job, and so a job for a laboratory technician, which I obviously always had a bit of an interest in science, so that appealed to me, but no idea what refractories were, which was a laboratory technician for a refractories company. Despite the fact that my dad worked in the steel industry for 50 years, I'd still no idea about refractories. So I applied for the job. Didn't actually get the job. I wasn't successful. They took on a different chap who lasted about 2 weeks, and then found out afterwards I was actually the second choice. So primarily the reason for that was because it was quite a manual and physical job that the rest of the people there, that were all men and young lads, were concerned about having a woman working in that environment. So they went for the chap who was an ex-Navy guy and lasted 2 weeks, and I was the second choice, and that was nearly 30 years ago now.
Gosh.
So yeah, so and then it started from there. So I got the job as a lab technician, learnt from the ground up. They sent me on day release courses. So I got HNC in chemistry and a degree in chemistry, but was also able to progress and gain the practical experience as well. And that was it. It developed an interest and a passion, and the rest is history, I suppose.
So you're just given a fantastic example there of sort of a modern type apprenticeship where you're learning on the job. But, you went on and got your BSc in applied chemistry from Sheffield Hallam University as well.
That's correct.
So you've got the theoretical and the practical at the same time.
Yeah.
And you've obviously climbed the career ladder as you're now a technical director at Trent. And prior to Trent, you were at another company for about 17 years, weren't you?
Yes, Vesuvius, yeah.
And I know that on your sort of LinkedIn profile and on the Meet the Team on Trent's webpage, it says that you've worked your way through the ranks in a major refractory company before going to Trent.
Yeah.
And I assume that gave you a good grounding of all the different practical and technical aspects.
Absolutely. I mean, I consider myself very blessed in terms of the timing when I came into the industry. And again, starting from the ground up, I learnt from a lot of really good people. So it was a time when it was still quite well invested in. Even the steel companies, everyone had refractory experts. So there was a lot of people with a lot of knowledge and experience to learn from. And I was very fortunate in being able to work alongside these people and absorb a lot of their knowledge. And then also working for Vesuvius, the technical facility at Vesuvius was very well stocked in terms of the range of different equipment that they'd got. They'd got a little pilot plant facility, but they'd also got a lot of investment in terms of analytical techniques so that you could get a really good fundamental understanding of all the materials and the interactions and things like that you just cannot get anywhere else. So you'd got that really good mixture of experience, having the academic side of things by being able to go to college and university, but also being able to apply that and learn from that by looking at things in very a high level of detail and getting that, again, pushing the boundaries and getting a real good understanding of things.
And the lab work, I suppose, involves a lot of, I can never say this word, microscopy.
Yes, yeah.
And scanning and looking down into the materials that you use and making sure that they're going to be suitable for the end result. Because you can't have a failure in what you do, can you?
You definitely cannot have a catastrophic failure, because it can literally end in very serious consequences and an injury and high cost to the customer. I mean, at one bit they were talking about for petrochemical industries, if they go down, depending on the severity of it, then you're looking at £1 million a day consequential losses. So there's a lot of pressure and responsibility in terms of developing and recommending and specifying the right material. So absolutely, you have to have a look at and a good understanding of everything. And it's not just looking at just one test, because there's a lot of emphasis in terms of data sheets that you'll look at certain physical parameters, but really it's like a jigsaw, and you need as many pieces as you can to get a good picture and understanding of what is happening and what these things are going to be subjected to, and then you can make the appropriate decisions and judgments.
And you said you've been doing this nearly 30 years, so obviously over that 30 years, the materials that you use will have changed and developed and evolved. Is there anything that you used to use 30 years ago that you no longer use, that's been replaced by something else, or is it still fairly traditional, just been tweaked a bit?
I think the refractories industry in general tends to be very traditional. I mean, people talk about innovation, and I think it's more in terms of innovation in terms of how you use materials. I think for me, one of the biggest things that I've seen over the time I've been there is is the change in terms of suppliers. In the past, it used to be, we would set the standard of the raw materials that we wanted, and then we didn't really have a problem in terms of getting that. Over the time I've been in the industry, that's changed significantly. That now it seems to be that the raw material quality is not as it used to be for various reasons. The actual ore and deposits are not as prevalent as they used to be. Obviously, there's conflict, which affects supply, energy prices. So really, the challenge is trying to maintain and push performance standards, but while still trying to accommodate and utilise whatever materials are available, and make sure that we can do that at the right cost as well. So the biggest challenge for us, certainly I would say for the last 10 years, has been raw materials driven in terms of sourcing the right materials, and then also having to understand how the raw materials have changed, and then adapt to be able to utilise those in products without it affecting performance and quality.
And that's the thing, isn't it? When you're using natural materials from ores and things like that, you're going to get a variation. That it's not plastic that you can make, number 1 and number 20,000 the same. When
Yep.
you're actually using something that's been dug out of the ground, there's going to be a natural variation in them, and it's having the knowledge and the experience going hand in hand to be able to assess that and adjust, isn't it?
It is, yes, and that is the thing. It's you can't learn that from a book, unfortunately. It's about being able to adapt, understand, because there's so many things it can affect in terms of water demand, in terms of how it interacts with other materials in there. So the flow, which will then affect the placement, the setting time, whether you need a certain length of time for it to be workable before it goes hard, but then you also need for once it sets, once it's become hard, that also needs to be done within a certain time, and that's very temperature sensitive to other impurities in the raw materials. So actually having the knowledge of how these things interact at a very sort of microscopic level in some respects, you're really talking about sort of surface chemistry effects. There is a lot of knowledge and understanding that's required in order to be able to do that, and of course, many times we're doing that as it happens live. We're having to make decisions. We don't have the benefit of months of being able to study these things. We can be in the middle of a cast and they start to have a problem, and we have to react and respond. Otherwise, we lose the cast. So, it's very hands-on.
It sounds like it. And also, I suppose now, with your experience and your role, you're in the position where you're transferring your knowledge to the younger people coming up, and the people who are learning and gaining that experience from you as well, aren't you?
Yeah, and to be fair, that's one of the things I've probably enjoyed the most about coming here to Trent, because you can work with the guys on the shop floor. We're a very small team, but we all work very well together. So now we've overcome the boundary of in terms of them raising issues. They're quite good at coming and telling us when there's an issue, and that we'll work through that together. And so we're actually helping improve their knowledge and their understanding, so they get involved more and more in terms of the problem solving, which is very helpful as well. Because the more that people can engage and pass information on, the easier it is to pinpoint the problems quickly, and we can then react to that appropriately. But we've also got a young apprentice. So because of the way that I came into the industry and progressed within the industry, I'm very passionate about paying that forward and continuing that. So we took on an apprentice 2 years ago now, and he works in the lab alongside myself and some other colleagues, and he's progressing very well. And again, it's really good to see how he's coming on. In fact, we had a student from Exeter University come and spend a week with us a couple of weeks ago, and our apprentice technician Eustace, he he was spending a lot of time going through, doing the work with him, doing the mixes, explaining the process, and it was quite a proud moment, really, just sat listening to him and how he was sort of communicating and explaining certain things, and that was very rewarding as well. So it is nice to be able to pass that knowledge on, just like I benefited from that when I started in the industry.
That sounds like absolutely wonderful. I think with younger people, quite often if they're working with, a small company and, the next youngest person might be 10 or 15 years older than them, finding that voice and having the confidence is a skill in itself, as well as learning, the skills that obviously he's learning from yourself and your colleagues. And it's always nice to sort of hear them confidently sort of start talking about something, and you can see that they've learnt it, they understand it, and they can apply it.
Yeah.
Are you looking to get more apprentices in the future?
I think as the business develops, and certainly as Eustace progresses, then it's something I think we'd like to do. And so obviously we'd like Eustace to get career progression. We hope that he'll stay within the business once he completes his apprenticeship next year. And so that he can stay in the business, and then we can look at maybe taking on another apprentice so that we can keep that ball rolling.
And you said right at the very beginning that the castings that you do can be 1 kilogram to 10 tons.
Yeah.
So that's a huge range. What are the smallest ones used in compared to the largest ones?
Generally speaking, they again can be used in different industries. But the smallest ones we use tend to be just a component part for, again, in the steel industry, but this tends to be more in terms of the sort of the finishing end of things. So when they're doing the casting after they've processed the steel and refined the steel, then as they're actually then converting that into either ingot or slab, they'll have to put that in what they call a tundish, which is essentially like a bath with different plug holes that they can then drain the steel out and form the pieces. And so some of the smaller pieces are just used as support structures for some of the what they call submerged entry nozzles, just to hold them in place and to stop them moving around and prevent any sort of oxygen ingress that can cause major problems with the molten steel. And then the largest casts that we do tend to be used for electric arc furnace roofs. So where they've got the electrodes inside when they're doing electric melting, then they'll protect the roof with these big casts that can be, like I said, 10 ton. Not just arc furnace roofs, they can also use it for roofs for vacuum oxygen degassing and argon degassing. But the larger casts tend to be roof applications, mainly for the steel industry. And then the smaller ones, like I've said, again, can be the steel industry, but we've also done things as varied as pizza oven tiles that go into the food industry as well, and they tend to be quite small items as well for obvious reasons. So it's quite a range of different applications.
And along with that range of different applications, you've not only got the technical knowledge and experience that you and the team at Trent provide, but you have to expand that knowledge so you're aware of the environments that the casts are going into, because something in an argon gas chamber is going to have different requirements to something that's melting aluminium. So it's a huge responsibility and a huge amount of knowledge that you've all got.
Yes. Yeah. And again, a lot of that comes back to working in a big multinational company, because they pretty much dealt with every application. So I started off in steel and the iron side of things, and then moved into what the Vesuvius called industrial applications, which then that involves sort of the aluminium and cement, incineration, all the non-iron and steel type of applications, which is vast. And like you said, the interactions and things, just even down to the temperature differences. So aluminium is generally processed at, well, in terms of secondary aluminium making, it tends to be around about 800 degrees centigrade, whereas in terms of the steel, iron and steel side, you're looking at sort of 15, 16, 1700 degrees centigrade. So huge jumps in temperature, but the interactions, the fluxes that they use, and the corrosion mechanisms, they differ very significantly. And so as a result of that, the type of material that you select and use for different applications is also very specific to not only the industry, but the application within that industry as well. So yes, it's again comes back to a lot of knowledge and experience and learning from other people.
One of the things I always find, because I've sort of done this for 34 years, is that somebody will ask me a question and I'll go, oh, hang on. Right, okay. And you'll go, we did something similar to that in about 1992. And it's amazing just the depth of memories
Yeah.
that you can pull out for experiences that you've had. And you sort of never really forget it.
No, that's the thing. It's you once you've gone through that, and especially if you've spent a lot of time sort of, again, I've had projects where I've done a lot of work on aluminium corrosion mechanisms and looking at interactions of different salts and fluxes on that, and because you've looked at that in that level of detail, you just don't forget that. And likewise, in terms of just not just the actual material side of things, we get involved in terms of the installation and application. So again, I've spent months on projects involved in terms of different gunning configurations and how that affects material installation. And again, that is very helpful when you've got problems, having that practical knowledge, because you can have the best material in the world, but if it's not installed properly or they have problems during installation, it just won't work. So it's not just the material side of things, the practical aspects of how it's installed and when things go wrong is also very important. And again, it comes back to, I'm a very practical learner. So actually, once you've gone through that and you've seen that and you've been there and you get an understanding of the things that affect it, you don't tend to forget that. It tends to help, and then you can apply that to other aspects where you encounter similar issues.
Do you find now that because you sort of had sort of what nearly 20 years at Vesuvius, going through the different departments, working on projects, that now you're the technical director at Trent, you get to experience the best of both worlds?
Yes, I think I really enjoyed my time there, and I valued everything I learnt at Vesuvius. There was some incredible people there as well. Um, but actually coming to work for Trent, because it's smaller and it's owned by Katie, we can be a lot more responsive, and so we can implement change a lot quicker. And I actually really enjoy that aspect of it as well. So we have a lot more direct engagement with customers, which I think from a technical standpoint is very helpful. We're a very close team as well. So in terms of understanding the business priorities and knowing what the sales team needs or what the production side needs, we very well connected in terms of that aspect. So I think being able to apply all the knowledge and the learnings from working in a corporate company, it really does help when you come to a smaller company, but you can then make that change a lot quicker, and I enjoy that because you can see the consequences, the impact of what you're doing you can see that a lot more quickly than what you can when you're working maybe in a bigger corporate company.
It sounds like you've got such a wealth of experience that it's going to be fantastic for the team that you're working with, for them to draw on that, but also for you to draw on their experience.
Exactly.
And I'm sure you give each other advice all the time. So one final question. What's the best piece of advice you've ever been given?
Oh, that's a tough one. But I think I think in terms of advice, then it probably goes back to when I very first started learning, and that's just to check and question if something doesn't seem right or you don't understand, then don't be afraid to ask, because it's the only way that you'll actually get to the bottom of things. So yeah, it's just, you know, you do it in the right way, but basically, if people are telling you something and say, for instance, something can't be done in a particular way, then don't just accept the fact it can't be done. Try and understand what the barriers are, and then see if there's ways that you can overcome that. But really, just try and, you know, get that understanding. Don't just accept that things can't be done, or that this is the way that it's always been done. Just challenge it and try and understand why, and develop that understanding. And then, you know, once you understand that and what the issues are, you can then maybe, you know, identify ways to overcome that and move forward.
Thank you so much for coming on to the podcast, Zena. I've learned a lot more about refractories, and it's been an absolute pleasure to talk to you. Thank you.
Thank you very much for having me. It's been an experience, something I've never done before, but I thoroughly enjoyed it. So thank you very much.
And I'm just hitting stop.